So now, here we have an LM358 wired as a ramp generator. I go to the negative supply here, and there we go, now I finally got it connected. We get a steady rising voltage. Go to the negative supply, we got a steady lowering voltage. If I jumped instantly from positive to negative supply, then it would be a triangle wave, especially if we had a 50% duty cycle. But any case, we are going to wire that to just keep lowering the voltage till it gets nothing. So, again, we have the LM358. At the plus input, I have two equal value resistors set half the supply voltage. At the output to the inverting input, we have a negative feedback capacitor. That's how you get ramps with the op amps. 0.47 microfarad, half of a microfarad. 4.7 million ohm resistor that I'm using there. You could use different values. But that's coming to this jumper, which I can go directly to the positive supply or negative supply. So now we're going to look at the schematic of my LM358, which I wired as a ramp generator. To get a steady square wave input, you will get a triangle wave generator. But in case we have half of the supply voltage to the non-inverting input, I'm using 12 volts, so we got 6 volts right there. And of course, remember, it's always comparing those two voltages. The output's trying to make those two voltages equal the best it can. So we have a negative feedback capacitor. That's the secret to getting a ramp right there. 0.47 microfarad. And then a 4.7 million ohm resistor there, which sets the charge and discharge time of it. You know, how steep the ramp is ultimately, the voltage change. So if you got a square wave input of, 0 to 12 volts right there, then the output is going to keep going up and down in the opposite direction to try to get those two voltages equal there. And you can add an LED where it gets brighter with higher voltage and dimmer at lower voltages.